Kc or Kp. You have studied this equilibrium constant in
Yes.
terms of concentration and pressure. And if a reaction is given like this, just take an example of like this. Let me take an example of CuSO4. It is in aqueous solution plus Zn solid. That will give you basically that will give you ZnSO4 plus Cu. This is now in aqueous and this is in solid. Can you write the expression for Kc?
Kc, its E naught cell is equivalent
No,
to
no, 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 no. Kc is
no,
equal
not
to
that.
what? No,
Oh,
no, not
Kc.
that. I'm
Oh,
asking about the concept that you have studied in class 11th, chemical equilibrium, in which you have written the expression of Kc, not in terms of this electrochemistry, not in terms of E naught cell.
okay.
Okay,
I
that
don't
is
know that, sir.
basically, yeah. So basically, this is product upon reactant.
Yeah,
And
yeah.
you can see, to be more specific, this is your product, right?
Yes.
And this is your reactant. So always remember that whatever is in product, you are going to neglect pure solid and pure liquid. Pure solid and pure liquid, you are going to neglect it. Are you guys
Okay.
getting my point? Actually, its value is 1. So you just neglect it. Active mass. Okay. So you can see this is in aqueous. So you will take it. You will take it. And it is, if you are going for, it will be like this, just ZnSO4, and you are going to neglect it. Now come to the reactant part. You can see again, this is in solid. So you are going to neglect it and you are going to write this part. Are you getting my point?
No.
No.
Sir, can you say it again?
Yeah. Product upon reactant, right? Product upon
Yeah.
reactant.
Yes, sir.
So how many products do you have? Two products. ZnSO4. This is concentration. CS stand for concentration of ZnSO4 into this is product
Yes.
and this is your reactant. Yes or no?
Yes, sir.
But I told you that in pure solid, that means the one which is present in solid state or liquid state. I'm covering the both part. Here only solid state is present. But if it is in pure liquid state also, you are going to neglect it. Basically, its value is 1. So we don't represent it or we don't show it. So the final expression will be ZnSO4 upon CuSO4. Are you getting my point now?
Yes. Yes, sir.
Kc is product upon reactant. Now, the product should be either in gaseous state or in aqueous state only. Then you are going to write it in expression. Otherwise, you are going to ignore it. Okay.
Okay.
Is that clear? So it's very easy. Product upon reactant. Now, how you are going to calculate whether what is the value of n? So what I told you is basically it is n is basically number of transfer of electron, number of electron transferred. That means basically there will be some loss or gain of electron. The number of electron lost will be gained by someone else. Okay. Now see, can you calculate the oxidation state of this part? Cu, oxidation state. Yes or no?
Cu2 plus.
Why you just uh, you didn't calculate it. You didn't get it. You always use this Cu plus 2. That's why you told me Cu plus 2, right? 2 plus.
Yeah.
Yes or no? Yeah. So don't go like this because it is coincident. Okay. So
Okay.
can you tell me this is SO4 and it has always negative -2, which is known as sulfate,
Negative.
right?
Yeah.
You know this, the SO4 -2, it exists in
Yes.
-2
Yes. Yes.
sulfate. Now come to the point, if there is no charge, when they combine together, there is no charge. Initially, it has -2, that means it must have +2. Yes or no?
Yes. Okay.
Now, there is a logic behind this, right? Whatever I told you just.
Yeah.
Now, tell me, what is the oxidation state of zinc here? Can you tell me? I told you when we studied this electrochemistry. Basically, whenever any substance which exists in elemental form like this or in molecular form like this, they will have oxidation state 0. Always remember this. This is very important. Are you getting my point?
Okay. Yes,
Now,
sir.
can you tell me the oxidation state of copper here? Just apply the concept, you will get the answer.
It's again 2 plus.
No, what I told
It's
you.
0.
Yeah, you were just what to,
Okay.
it is in elemental form, right? What I told you, you have
Yes.
to keep it in mind, or else you are going to write it in your notes that the oxidation state, just wherever you have written the notes for electrochemistry, just write there. Just after the name of the chapter, you are going to write it. The oxidation state in elemental form or molecular form will be zero because it won't be given, and you cannot apply any logic there like this, but it's easy. Oxidation is state is about basically lose or gain. So if it is alone, neither it loses nor gained, that means it is zero, right? There is a logic also.
Yes, sir.
Are you getting my point? Now come to this
Yes, sir.
point, ZnSO4. Can you tell me the oxidation state of zinc? Apply the concept whatever I just told you in this
Sir, it will
procedure.
be sulfate will be -2 and zinc will be
Zinc will be plus
+2.
2. Yes, it will be.
+2, yeah.
Very good. Now, for this reaction, what is the value of N? You can take any one of them. Like you are just differentiating between copper and zinc, and you can take only one of them. Since the reaction is balanced, right? The reaction is balanced now. One copper on the left, one
Yes.
copper on the right, zinc on the left, one zinc, so all balanced. Now, see, zinc is varying from 0 to plus 2, right? 0 to plus 2, right? Zinc is varying from 0 to plus
Yes.
2. If some element is going from 0 to plus 2, what does this means? What does this means to you? Can you tell?
Loss, gain of electron, oxidation,
Hmm.
right?
Gain of electron is oxidation.
Gain of
Yeah, you just got confused.
reduction.
Reduction. But if it is going from 0 to plus 2, what does this means? Gain or lose? What I want to ask is that.
Gain of
No, 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 no. Whenever you are going to lose electron, you will have positive charge. If someone is gaining electron, they will
yeah.
have negative charge because electron has
Oh,
negative
right.
charge. And if I lost it, I will get positive charge. And if you will gain
Positive
it,
charge.
you will have negative charge, right? So
So
0 to
yeah.
plus 2, 0 to plus 2 is loss of electron, right?
So oxidation. Yeah.
Oxidation. Now, tell me, if this zinc is going from 0 to plus 2, how many electron does it lose? How many electron it
Two.
just lost? 2. So that's why Na will be equal to 2. You don't need
Oh,
to go for
okay.
this because if it loses, who will gain? The one which is copper, right?
Yeah.
Are
Okay.
you getting my point? Uh, if you will, if
Yes.
I will give you 10 rupees, you will get 10 rupees only by me.
Yeah.
Are you getting my point? It's just like the reaction. If in this reaction zinc is losing 2 electron, copper will gain 2 electron. Not copper cannot gain more than 2 electron because only these two components present in this, right?
Yes. Okay.
Okay. So let me ask you some more question. Okay, first of all, you are going to write a reaction for this representation. Always, whenever it will be in ionic form, you know what is ionic form? There will be charge, right? That will be in gas,
Yes.
aqueous state, and whenever it will be in elemental form, it will be in solid
In
state.
solid state.
So
Yeah.
you are going to write a reaction for me here, and then let me know the number of electron gained or lost.
Sir, sir, it would be one.
It would be one. Did you write the
One.
reaction? Did you write the reaction?
Mm, no, but then I wrote
Good.
in the form of like Ni plus Ag plus giving rise to Ni plus 2 plus Ag. That I wrote it
Oh,
like
you
that, and
wrote the
then
reaction. You wrote
you
the
mark
reaction,
which
right?
one is oxidation.
Okay, okay.
Yeah, yeah.
So whenever you are going to calculate the number of electrons, you need to check whether it is balanced or not. Did you check it?
Oh,
No.
no,
You just
no.
need to check it. First, you are going to check it.
Sir, would it be like 2Ni plus Ag plus giving rise to Ni plus 2 plus Ag?
Do you know how to check whether your equation is balanced or not? Yes or no? First,
No.
okay. First, first of all, what is your first step? Just check if number of atoms are balanced or not. Number of atoms. Is it balanced? Just check it and let me know. Number of atoms balanced or not. Whatever is the number of different elements present on the left hand side, is it equal to the number of atoms on the right hand side? Yes or no? Nafisa?
Yes.
I asked something. Did you hear that?
Yeah.
Yeah. Is it
I
balanced or
wasn't.
not? Okay, just send me. Just send me. Do you can you send me right now? Can you send
Okay.
it to me right now? Okay. You need to do a little bit more hard work, and it's easy, very very easy. If you are going step by step, it's very easy. Okay, thank you.
Sir, I sent it to you.
Yeah, yeah, I got. Just let me why it is. mm, How to rotate this? Mm, Copy is here, and I'm gonna paste it here. Can you see this?
Yes, sir.
Okay. Now you have written the reaction as Ni plus Ag plus, which is equal to Ni plus 2 and Ag. What I told you, the first step to check the balancing is the number of atoms, right? You can
Yes,
see
sir.
one Ag plus one Ag. That means atom is balanced. The
Yes.
second, which is very important, is your charge. Is there any charge on this? No, no charge. Yes or no?
Yes, sir.
Here
No.
it is plus one, right? That means on the left hand side you have
Yes.
plus one charge. Now, is there any charge on this? No. So it is zero. But there is a plus two charge.
No, sir.
So on the right hand side, it is plus two
Yes, sir.
charge. Is charge balanced? Plus one on the left and
No.
plus two is on the right. So you are going to balance it. And how you are going to balance it? Wherever the charge is lesser, you are going to multiply something so that it will be balanced. Now, If you are going to look at this equation, you will see that the charge is balanced. The charge is balanced because on the right hand side you have plus 2 and on the left hand side you have plus 2, but the atom is not balanced. So in order to do the atomic balance, 2 Ag is there, so you are going to multiply it by 2. Now it is balanced, isn't it?
Yes, sir.
It is balanced. It's so easy. Now you can say what is the oxidation state of nickel is 0. What is the oxidation state plus 2? Oxidation took place here
Yes,
and
sir.
number of electron will be 2. Or either you can check from here. It is plus 1 and here it is 0. So plus 1 to 0, that means it gained 1 electron. But there is 2 Ag. For 1 Ag, you have 1 electron gained, right? So, but there is 2
Yes, sir.
Ag. That means number of electron gained is 2 and that's why n is equal to 2. Are you getting my point?
Yes, sir.
Now I'm going to again tell you how to. This was my question, right? This was my question. Ni plus 2
Yes.
slash Ag plus slash Ag, right? Now, how you are going to write a reaction? It's very important. This is your oxidation part, as I already told you, right? Oxidation, and this is your reduction
Yes,
part,
sir.
right? This is your anode, and this is your
Yes.
cathode. So you are going to write oxidation half reaction first. So Ni is going from Ni is going from Ni to Ni plus 2, right? That means it
Yes, sir.
lost 2 electrons. And here you can see reduction half reaction. You can see Ag is going from plus to Ag. That means it gained 1 electron, right? Yes or no?
Yes, sir.
Whenever there will be difference of electron, like if the electrons are not same, if the electrons are same, you are going to add it, electron will be cancelled by each other. But if you will get a different electron, then whatever the number of electron is here, you are going to multiply in here, and whatever is the number of electron here, you are going to multiply in here in this, so that electron will be equal and it will be cancelled. So after multiplying, you will be getting the first equation Ni. Since you are multiplying it by 1, so it will be as it is. But if you are going to multiply it by 2, you will be getting this, and then you are going to add it, you will be getting the complete cell reaction or complete reaction to Ag plus. Now you can see it's Ag plus, not Ag plus 2, it is Ag plus. And you can see this is your Ni plus 2 and this is your 2Ag, and this will be cancelled, right? So this is your equation, and from here you
Yes,
can
sir.
see n is equal to. So it's very easy. You need to, I in the class I give so many questions to practice on this, right? So
Yes.
let me know if you still have any doubt in this. Can I move to the
No,
next
sir.
part?
Yes, sir. Okay.
Okay. Okay, so I'm going to give you a very, very easy question. Can you hold on a minute? Okay. So find, question is, E cell. What is this? You need to write a reaction if the reaction is not given in the question. For E cell, you are going to apply which formula?
For E cell cathode minus E cell anode. Is it the
Yeah.
no for E cell? Oh, okay. For E
Nernst
cell,
equation it
it's
is.
the E naught cell.
In Nernst equation you are going to use, right?
Oh yeah, yeah. It's that
Yeah, yeah.
E naught cell minus the 0.
Yeah, 0.059 log product upon reactant. Are you able to solve it? Yes or no?
No, sir.
And then what you are doing? Can you send it to me? Whatever you have done.
Sir,
I just want to
sir,
check
it's
it.
wrong.
Whatever you have done, just send it back to me, please. I need to see what you write after. Question.
Sir, I didn't realize the 0.75 was,
Oh, that's
yeah,
okay. But what is
yeah,
this?
that one I didn't realize that. Yeah,
How many CR is given in the representation?
yeah, I know one. Yeah, it's a,
Two,
yeah,
two CR.
two.
And the
In
reaction you have
another
written
one,
is 4 CR, right?
it's wrong. Yep.
Now see how you are going to write. This is a half cell reaction is given. So you need to
Yes.
write the half reaction only. And CR
Yeah.
is
Okay.
going into CR plus 3. Now you can see
Yes, sir.
this is 0 and this is plus 3. That means it loses 3 electrons. So you are going to write plus 3 electron here because it lost 3 electrons, right?
Yes, sir.
Now this is the reaction. Now in order to calculate E cell, you have the formula E naught cell minus 0.059 upon N log of product upon reactant, right?
Yes,
Now,
sir.
what I told you, whenever it is in aqueous state, sorry, in ionic form, it is in aqueous state, and this is in solid state, right? Yes or no?
Yes, sir.
Now, come to the main point. What is the value of N you can conclude from this reaction?
Three.
3. That's good. And the value of E naught cell is also given here. So, no need to worry and apply the formula, right?
Yes.
The whatever is written here 0.75 minus 0.059. Value of N, you just told me that it is 3 and then log of
Yes,
product.
sir.
Product is this, so you are going to put it Cr plus 3 and
CR plus.
reactant is in solid state, so you can neglect it, right? You
Yes,
can
sir.
neglect it. So you are going to write it now. Minus 0.75 minus 0.059 upon 3 and here it is log. What is the concentration? Concentration is given as 0.01, that means 10 raised to the power minus 2, right?
Yes, sir.
Log 10 raised to the power minus 2. Now you just need to solve it. So what I'm going to do, I'm just going to solve it. It is minus 0.75 minus, I'm going to round it off. Can I write it 0.06? Yeah, and 3 is here. And you can see this is your minus 2. So log a raised to the power n will be coming here. So it will be minus 2 into log 10. And I already told you that log 10 has a value 1. So what you need to do, 0.75 minus, you can easily cancel this 0.02 times. And when it is going to multiply minus into minus, it will be plus and 2 to the 4. So it will be 0.04. And if you are going to solve it, you will get 0.71 volt, right? Isn't it easy?
Yes, sir.
That means you are not revising your notes because this question is exactly the question in the notes. Are you getting my point?
Yes, sir.
So you just need to first revise the notes, whatever is the question you are going to solve it. If you are getting problem in that, first you are going to solve it on your own. And if you still have any doubt in that, then you should send it to me so that I will be able to explain. Okay. So can I change the
Okay.
slide?
Yes, sir.
Okay. The next question, calculate again E cell of it is given. You just need to write first the equation, which is very important. Slash Fe solid. Not a problem. It's okay. At 25 degrees centigrade and E naught is given. That means E naught cell is given. Fe plus 2 slash Fe, or is it plus 3? Okay, plus 2 is given as minus 0.4. Apply the same concept that I just explained and send it back to me.
Sir,
Yes.
sir, in like the product and reactant, how did you get 10? Like 10
And
minus 2. Yeah,
oh,
10
it
raised to the
was
power
basically
minus 2.
you are talking about this 0.01, right?
Yeah.
And there is also the
No.
same value. There
Oh,
is
okay,
a,
okay, yeah, yeah, yeah. Okay, I understood. Okay,
you can
I'll
see
do.
this will be written as 1 upon 100, 10 raised to the power 2, and when it moves to the top, it will be like this, right?
Yes, sir.
Okay, I'm waiting.
Sir, the answer is 1.44.
Is it 1.44? Might, can you send it to me?
Okay.
I just need to see how you have solved it. Yeah, I've got it. I just want to show you what you have mistaken and where you have mistaken. Mm,
Sir, what did you say?
mm, I just want to show you what you have done correctly and what where you have mistaken this.
Okay. Okay.
And it's also important to note how you write. Okay, so first of all, the first mistake comes here, and that is you didn't write the correct equation because if Fe plus 2 is going in Fe, that means now its oxidation state is 0, right? Plus 2 to 0.
Yes.
It,
Yeah.
gained electron or lost electron? What do you think?
Lost.
Lost.
Gained.
Plus 2 to 0. That means it gained
Yeah.
electron. Whenever the
Yeah.
oxidation
Gained.
state decreases, always remember that whenever the oxidation state decreases, it is gained, it has gained. And whenever it loses, it has lost. Okay.
Yes, sir.
So the
Okay.
first mistake is here. You didn't write plus 2 electron. Now move to the next. Is equal to not cell, that is good, 0.059. You have written it correctly, the value of n. And log of product. Product is in solid state, so it will be 1, right? Here it will be 1, yes or no?
Yes.
And it
Yes,
is
sir.
Fe plus 2. So how it becomes 10 raised to the power minus 3 when it is it is 0.01, that means 1 upon 100, that means 1 upon 10 raised to the power 2, that means 10 raised to the power minus 2. It is 10 raised to the
Oh,
power
okay.
minus 2, right? So when
Okay.
it
Yes, sir.
comes here, it will be like this, and you just cancel it 0.03 times. So it will be when it you are going to multiply it by this. So it will be like this is a value 1 and it is 0.45 minus, and you are going to multiply it by this. So you will get plus 0.06, right?
Yes, sir.
And log 10 has a value 1. So you just multiplied it. Rather than subtracting, you multiplied it, right?
Yes. Yes, sir. I did.
Okay, one more thing that is wrong is that uh, initially I couldn't notice it, but it is wrong that let me write from here. Minus 0.45, you have written it correctly, and this is, I'm going to round it off, and it is log, and log minus 0.06 upon 2, log of 1 upon 10 raised to the power minus 2. It will be like this, yes or no? Because the concentration has a value
Yes.
10 raised to the power minus 2. Now you can see when it will move to up, it will be in positive, yes or no? Just let me know.
Yes. Yes, sir.
So this is the another mistake that you have done, and you are going to cancel it. It will be 0.03. Now 0.45 minus this will come here, and it will be 0.03 into 2 log 10, which
Oh,
has a
okay.
value 1. So you can see minus 0.45 and minus 0.06, that will be equal to 0.51 basically. Yes or no? 5 plus 6,
Yes.
11, 4 and 8. So this will be your answer in negative. Are you getting my point?
Yes, sir.
So see, it's very easy. What you need to do is just write the correct equation. Are you getting my point? So
Yes,
this
sir.
question is also based upon half cell reaction. Now I am going to give you to apply the nurse equation for full cell reaction. Okay. So I'm going to
Okay.
write the formula. Find EMF of cell, that means E cell. Find EMF of cell at 25 degrees centigrade. And it is given that, wait a minute, please. Okay. And it is given that CR slash CR plus 3, 0.1 M, double slash Fe plus 2, 0.01 M is given, slash Fe, which is in solid state. This is also in solid state. And it is also given that E naught CR plus 3 slash CR is equal to minus 0.75. Now, you in order to calculate in Nernst equation or put the value in Nernst equation, you are going to calculate Nernst equation. I'm going to give some hints to this question first. So you know the formula E cell we need to calculate. E cell is equal to E naught cell minus 0.059 upon n log of product upon reactant, right? Yes or no?
Yes, sir.
Now see, first of all, what is E naught cell? So when you are going to, you need to calculate from here. You know E naught cell will be equal to E naught cathode minus anode, right? Or E naught right minus left. Do you know
Yes,
that?
sir.
So you can see this
Yes.
is your cathode, this is your anode. That means you are going to subtract from this, and product upon reactant. N you can calculate when you are going to write the reaction. You will get the value of n. And when you are going to write the reaction, you know what is the product and what is the reactant. So please give it a try. Are you done with this?
Sir, wait, sir.
Okay.
Sir, minus 0.58 volts.
What you just said, minus 3 point.
0.58 volts.
Okay, so first of all, I'm going to write the. Can you send it to me?
Okay, sir.
Please do send it. Yes, I need to see. What is your answer? The final answer is not in the in this,
I
right?
send Sir, I send the final answer.
Minus 0.58 is your answer, right? So again, the
Yes.
same mistake, I think. Can you tell me? Okay, the mistake what you are doing, you are doing the mistake in calculation. So first of all, let me show you the mistake. So first of all, what is the value of E naught cell? E naught cell has a value 0.3, right? This is correct. E naught cell
Yes. Yes, sir.
0.3 here, 0.059, and where is the equation? This is the equation.
Yes, sir.
So equation is 2Cr plus 3Fe plus 2. Why it is 2? Is it 2 here? Is
Yes,
it 2?
because
Okay, let me show you.
two, it will be 6.
Yeah, it is wrong. It is wrong. Now see. The representation is like this. Cr plus 3 double slash Fe plus 2 slash Fe. Like this, yes or no? Now this is your oxidation,
Yes,
this
sir.
is your reduction. So can I write Cr is going in Cr plus 3? That means it lost 3 electrons. Now this is your
Yes.
what? This is your reactant. So it will gain, sorry, reduction. So it will be like this. Yes or no?
Yes,
This is
sir.
your oxidation half reaction and this is your reduction half reaction. Now what I told you, whenever the number of electron is varying, then you are going to make it equal. So this is 2, so you are going to multiply it by 2, and this is 3, so I'm going to multiply it by 3. So
Okay.
what you will be getting, you will be getting 2Cr plus, so not plus, arrow, 2Cr plus 3 plus 2, 3 is a 6 electron, and here it will be 3Fe plus 2 plus 6 electron. Now the electrons are equal, 3Fe. Now if you are going
Yes,
to
sir.
add it, you will be getting 2Cr plus 3Fe plus 2, and electron will be cancelled, right? This electron
Yes,
will be
sir.
cancelled since they are equal. Now you can see, if you are going to move to this part, 2Cr plus 3 plus 3Fe. Now this is in solid and this is also in solid, and the one which is an ionic are equals, right?
Yes, sir.
One thing you have done it correctly is your E naught cell, which is 0.3. So I'm directly going to take it 0.3, right?
Yes, sir.
Now, I'm going to apply the Nernst equation, which has a formula that you told me. E cell is equal to E naught cell minus 0.059. Now, what is the number of electrons? Can you tell me what is the number of electrons?
6.
6. And what you have taken? 6. That is good. 6. Log of product. Now you can see this is your solid, so you are going to neglect it, but the rest part you are going to take it. Now you can see this is your 2Cr plus 3. So this will be your concentration, and whatever is the coefficient that will come in power upon, you can see this is your solid, so you are going to neglect it, and this will be Fe plus 2 raised to the power 3. Are you getting my point?
Yes, sir. Okay. Understood.
Now can you again solve it? Please do solve it.
Okay.
You know the value of this, which is 0.30, and you know
Yeah.
this will be written as 0.06.
Yes.
Now you can see Cr plus 3 has a value 0.1. So can I write 0.1 as 10 raised to the power minus 1?
Yes.
This is 10
Yeah.
raised to the
10
power
raised to the
minus
power
2. So
minus
I
2.
want
Yeah.
you to, yes, I want you to solve it. 10 raised to the power minus 1 raised to the power 2, and 10 raised to the power minus 2 raised to the power 3. I want you to solve it.
Okay, sir. So the answer is 1.16.
Very good. And I still think that it is. Just let me check it. So you can see that this is 0.30 and this can be cancelled by 0.01, right? So this is
Yes, I did that.
right. Now you can see this
Yeah,
will be written as, did you
yeah,
did you do this correctly? When it will move
y-
upward, it will be
yeah. It will
10
be
raised to the
plus.
power minus 2 plus
Yeah,
6. So it will be 10 raised to the power 4, right?
or 4.
Plus
Yeah. Yes, sir.
yeah. So you can see this will be your 0.30 minus 0.01 and it will be 4 log 10, right?
4 log.
Log 10 is
Yeah,
the value 1
yeah,
and you can see 0.30 minus 0.04 and I think you just multiplied this number into this or this number
yeah.
into this. That's why it's wrong. It is negative here, no? So you need to subtract it and you will get 0.26 volt. You just need to multiply it here and here it is 0.30 minus 0.04. So you are going to subtract it. What you just did, multiplied,
No, I
right?
minus the 0.30 minus 0.01 and then multiplied by 4.
Can you again tell me?
0.30 minus 0.01 and then I multiplied by 4. The
Oh, that means you just subtract this and multiplied by 4.
Yeah, that's wrong, I think. Yeah.
This is,
Yep.
have you heard of this board mass?
Yes, I know. I remember just
No.
now. Yeah. It's yeah, yeah.
Okay, so take care of it.
Yeah,
Just
yeah,
don't do.
yeah. Okay, okay.
Okay, so this is it for today. Do you have any other doubt?
No,
Okay,
sir,
I
just that.
have sent. I had sent. Wait a minute. Uh, I had sent